So today we'll continue discussion the earthquake resistant architecture, and this part of lecture will be devoted to the basic structural schemes of earthquake resistant buildings. So first of all, no diagrams, sorry, schemes. Seismic resistance building. So first of all, let's discover this table. In this table, we can see main structural schemes of earthquake-resistant buildings, and the most earthquake-resistant building located in the top of this table, and less earthquake-resistant buildings located in the bottom of this table. So first of all, the most earthquake-resistant structural scheme is structural scheme made of steel frame, from steel beams, steel columns, etc. Those systems in regions with the seismicity 7 have no limits. It's like for they can be designed like for non-seismic hazardous territories. And next, it's monolithic or cast in situ reinforced concrete walls. It's 24. The limit top, the limited amount of floors of this building in regions with the seismicity 7 is 24, not more than 24 floors. Next level is prefabricated large panel reinforced concrete walls. The limit amount of floors is 20 in the regions with the seismicity 7. Next is reinforced linked or frame linked frames with the amount of floors 16. Less amount of floors has reinforced concrete flat slab frame with cores of stiffnesses, and it has limited amount 12 floors in these regions with the seismicity 7. Next is confined masonry, not more than 10 floors. Then complex construction walls with the limit amount of floors 5, and reinforced concrete flat slab frame without diaphragms, and wall maze of bricks and natural stone, etc. Small pieces wall element. The limit amount of floor 4. So it is the top amount of floor which for these structural scheme can be used in the regions with the seismicity 7. Next column is devoted to the limit amount of floors for the building located in the regions with the seismicity 8. So when we analyze this table, we can see that most of quake-resistant structural scheme is steel frame, and the less structural, the worse from earthquake-resistant point of view structural scheme is scheme with walls made of bricks. So that comparison is very important for you as an architect when you are choosing the structural scheme for the building that you design in earthquake-resistant region. So, and next part and next final model that we will have to discuss during our course is reconstruction and rehabilitation. So, first of all, we will discuss the ways of strengthening building structures depending on technological capabilities. So, first of all, the first way to strengthen the building structures is to strengthen them after dismantling structures or their individual elements that have to be reinforced. So when we use various cranes to take the structural element, it may be wooden beam or other wooden or steel element, We dismantling it from its place. We relocate it to laboratory where we reconstruct it and return it back and locate it in its previous position. It is the most expensive way, but it is very important when we talk about steel or wooden structures for unique buildings. Next way is to strengthen the structures without dismantling. So when we strengthen them in their working position, but with unloading. So in this case, for example, it's a residential building. We remove all vertical loads on the on beam or on the slab. We remove all equipment. We remove all hard weight structures and then strengthen them, and only after that we return the loads on it. We return those equipment, etc., that we have removed from this element. And the final way is to strengthen the structural elements without dismantling and in a stressed state. So it is in this case we consider the situation when we do not remove the loads from those elements. So those are three main ways to strengthen the structural elements, depending on the technological capabilities. Next question about reconstruction and rehabilitation that we have to discuss is are the methods for rehabilitation of structure. So first of all, we can strengthen the structural elements or structures in common when we change the operation conditions of structures. Next is the change of structural scheme and structural as whole or its individual parts. Third, regulation of forces and structures, and fourth, rehabilitation of individual structural elements and nodal connections. And all those four methods we will discuss on examples, on next examples. So, for example, when we talk about changing of the operational conditions of structure. So we have a big amount of situation where we have impact of underground water on our structure. So, and in this case, when we have to strengthen or to rehabilitate or reconstruct the building, when we change the conditions, when we protect our structural elements from impacts of water, of underground water, we are changing the operation condition of that structure. There are a very big amount of methods to change the operation conditions of structures. For example, also when we talk about roof constructions, which have various holes and openings, which gives the ability to water to rainwater to leak in those holes and those openings and to impact on the structures. In the case when we change or rehabilitate those roof structures, we protect the rest of structures of that building from impact of water, and that is the method of changing of operational conditions of structures. Next way in which we can next method which we can use to strengthen or rehabilitate the construction is to change the the structure's design scheme. And for example, as you can see, we can find these kind of cracks. As we discussed previously, such deformations can be caused by undermined territories. It can be caused by subsiding soils. It also can be caused by karst, subversion, etc. And in this case, we have the situation where, before those deformations, we have the situation where our structural scheme of building is located on the surface as one continuous beam. But in this case, where we have such deformation of soil, we can exchange the structural scheme of its foundation and to exchange it into a single and to make it work as a single supported beam. So here is one support, here is the second support, and in this case, this foundation of this building will work as a beam. And in that case, and when we make foundation element work as a beam, we are strengthening it with the way in which we can strengthen the beam. So here is our foundation, and we are adding such reinforced concrete element which gives an ability to work this foundation as a single supported beam. Next method of strengthening of structures is regulation of internal forces in structures. For example, we can add extra support. For metal structures, it is the easiest way because metal structures works in the same way like for compression and for tension. That is why it is really easy for us to add extra support to this beam, and in this case we will reduce the span in 2 times. So when we are reducing the span of beam in that ratio, when we reduce it in 2 times, in that case we are in that way we can find the extra reserve of bearing capacity of that structure. And in this case, we can also find the same solution by we can regulate internal forces in structures by adding extra elements which help to redistribute the load from the structure which we have to rehabilitate. Also, we can make rehabilitation of structural elements and their nodes by adding extra elements, as we talked previously, extra supporting elements. Yeah, and we can see the reduction of bending moment in this case because of these uh, extra support. In this case, we also can find this redistribution of bending moment. And in this case, we can see that the exchange of node of interaction of three separate single supported beam by making them work as one continuous beam. As you remember from previous lectures, from first module, difference between single supported and continuous beam lies in that we have support bending moments. And in this case, when we are adding those extra supports, no, sorry, not extra support, extra strengthening elements from the bottom, from the top, and in the middle part of the wall. This makes this beam work as one continuous beam, and in this case, we reduce that bending moment appear to well known for us, yeah, beam with support bending moments. It is a very good way to strengthen the bending elements. Here we can see also the way by adding extra struts, braces, brackets, etc. In this case, we are using those struts, and those struts give the ability to reduce the span of this beam. So in here we can see the big span, but when we adding this by adding this strut, so we are reducing the span from to this one. So from this node till this one, and this way, and in this way, we can strengthen the structural element. Same solution, but the length of struts is bigger. In this case, we are using struts which works on tension. Yeah, in this case, they work on compression, and in this case, they are working as a suspended structural system from our first lecture, as we discussed previously. And here are extra ways to strengthen the structural elements by adding extra elements and redistribution of internal forces on those elements. Also, adding of extra elements, truss elements give us an ability to redistribute internal forces also. Here are other elements which can it is strengthening of beam element by introduction and structural scheme of truss system. And when we adding that's the truss to beam elements, that can increase the bearing capacity of those bending elements. Also, we can find the ways to strengthen the bending elements like steel beams. And in this case, we are using additional elements which we connect with old element by using welding connection. Yeah, welding is a very good solution to connect these steel elements one to each other, including the situation when we are talking about strengthening of the elements. And here are main ways to increase the bearing capacity of those elements. Also, we can add plate elements or add additional bending element, which gives an ability to increase the bearing capacity of the element also. Next ways to strengthen the bending elements is strengthening of compressed elements like columns. And that way, on that slide, you can find the methods of strengthening of columns by using additional link element. And those link element can reduce the calculation height of element, or you can do it in this way or even in this way. Those elements are also a good solution to reduce the calculation height of those elements. Additional truss
Sorry,
elements, additional, yeah.
I want to ask which means racks and introducing puffs
It's on when we're
on
talking about,
presentation.
yeah, I see it, and it on those on that on this slide. So here we can find those puffs. I'll explain you. It's pre-stressed steel elements. In Ukrainian it's like попередньо напружені сталеві обійми. Puff and
Uh-huh.
braces.
Yeah.
It's like braces, like mm, I'll explain it. Braces. It's like links. No. In Ukrainian, it's обійми також. But puffs are for like these pre-stressed elements or truss elements, and when we talk about braces, it's more like these.
Okay, thank you.
So, and previously we have discussed all situations which are connected with metal elements, and also we have a big amount of cases when we have to reconstruct or rehabilitate reinforced concrete structures. Also, we can use two main ways for reinforced concrete structures. It's unloading elements, so to reduce the vertical loads on those elements, and to reinforce it or reconstruct it with concrete and reinforced concrete uh, additional elements, and I'll show you how we can make it. So for example, for this bending element, we can strengthen that element by adding additional cross section from concrete. And to connect the additional reinforcement which we use for this case, we can use such additional elements. It's reinforcement shorties, it's коротиші українською. So how can you connect all reinforcement, new reinforcement to the old one? So first of all, you have to cut or to fuck, I have forgotten this term, відбити зараз. So beat off by special equipment. We have to beat off the protecting layer of concrete, so we can see that old reinforcement. Then we are welding those reinforcement shorty, and here from the bottom part of this shorty we are adding additional reinforcement, and only after that we are placing the formwork opalku and adding reinforced concrete in it. So in that case, in that solution, we can add additional reinforcement to that bending moment. In this case, we can the solution to strengthen or rehabilitation of bending elements by adding additional element at the top of the element of bending element. In here in this solution, we can find the way of strengthening of the element by concrete reinforced concrete jacketing. And here is the form of this jacket that we add to this element. It's made of reinforcement. So here in the center we can see the old one beam. Only after that we adding additional reinforcement and adding formwork and pouring the concrete in that formwork, which give us the beam with biggest cross section with additional load bearing capacity. Also, in reinforced concrete for reinforced concrete beams, we can also use special metal truss elements, which gives us an ability to increase the bearing capacity of those bending elements. Also, we can use uploading brackets. Here, here it is. Here they are. Those brackets, which can also to reduce the calculation span of bending element. And here we can see also the way to reconstruct the column. So in this way we are adding reinforced concrete reinforced concrete jacketing for strengthen the reinforced concrete column. Also, we can use metal jacketing. Yeah, we can here can see those plates made of steel and those angles made of steel, and that those angles and plates makes one special metal metal cage which increases the bearing capacity of that reinforced concrete column. But main deal that we have taken into account it is fire protection of those elements. And for fire protection, we can the best way for us to add concrete or special paints which are produced for fire protection of those steel elements. Also, he can use three-side jacketing. Yeah, previously we have discussed jacketing, which you will perform from four sides of element that we strengthen. But in this case, we can find the three-sided jacketing. Also, there are some cases in which we have to reinforce the foundation, and on this slide you can see the situation where we can find all wall, old wall, and old foundation, and we have to. And in this situation, when we have to increase the bearing capacity of those elements, we are adding steel beam through the holes in the old wall. We adding such elements, and only after that we are adding extra jacket to that foundation and wall, and this increases the width of foundation. So, and we understand that it gives additional bearing capacity for such foundation element. And in this case, we can find the reinforced concrete jacketing of foundation from all sides. It's for the local foundation. Here, one additional case in which we are exchanging the scheme of foundation from located on the ground to the pile foundation. In this case, we are adding pile from both sides of building, making some make an additional beam, it's grillage or beam, foundation beam, and adding such bending element made of steel. And for redistribution of those local forces, we are using these and these additional beams. And this overall solution can give us an ability to redistribute those loads from this ground to these piles, which are located on both sides of the building. And here is the solution in which we can find the solution to strengthen the foundation, the corners of foundations of buildings. And here are three main solutions to strengthen the masonry. So we are in Odessa. We have a big amount of structures which are made from masonry, from bricks, and here are three main ways to strengthen them. So first of all, it is a metal cage. Uh, Next is reinforced concrete jacketing, and also we can find the smallest solution. With the smallest load bearing capacity, it is the mortar jacketing. So all those three solutions called jacketing, and first is made of steel, second made of reinforced concrete, and this made of mortar. And here are some cases from my practice, and here you can see the famous Odessa building. it's a historical architectural monument, and that is why we can strengthen them by adding jacketing to that building, because as an architectural monument it has a protection of its facades, so that is why we have to leave the external view of this building same as before reconstruction. That is why we have added those elements made of steel, which increases the bearing capacity of those walls. Here is one more situation. It is this building located not far from our academy, and in this case, we can see this white crack in this building. This situation located because this situation take its place because of this situation, because this part of foundation, so this wall is located on subsiding soils, but the rest of foundation of this building is located on the lower layer of ground on not subsiding soils. And when water leaked from this part, this made this soil to subside, and subsiding of this wall make it these cracks. So to stop those settlement, we propose this connection by adding additional piles to redistribute the load from this wall from this subsiding layer on those not subsiding layers of under that building. And here is the solution to to strengthen the walls of this building by adding spiral anchors in its walls. And here's one more architectural monument on Ekaterinинsk and Odessa. And here you can find the method of rehabilitation of these elements with adding metal jacketing from the facades of the building. And those metal jackets have to hold down those cracks which you can see on that on that wall of the building. Next situation, also on one of architectural monuments in Odessa, you can find those it also, by the way, you can see here vaulted arched slab right here, and it lies on bending beams. And here you can see the situation with those beams. Those are almost destroyed with the rust, and here you can see the sewerage pipe, which also almost destroyed with rust. Here are some additional beams, and you can see the state of those buildings. They are almost 100% consist of rust. Also, you can see those ladders. Those ladders are also part of of architectural monument, and it's impossible just to replace them with more than once, because you have to exchange them and rehabilitate them and return them back to this location, because it's architectural monument. And here is the way how in some cases engineers tries to hold down the movement of walls from solution. Also here you can see the great crack in the wall, and those cracks also can be strengthened by spiral anchors, as I showed you previously. In this case, we have a deal with a metal column in the center of the building, and it's not really easy for us to strengthen it, because that column is also is an element of architectural monument which have to be uh, which is protected by law, and it has to save its external view after reconstruction. Here are some cases from Odessa prison castle. Yeah, and you can see the state of our prison castle. It's sort of right now. It's sort of like a prison, and there are prisoners over there, and there's also a historical monument, and it also has to be protected. So here, that's all I wanted to tell you about our course. It's all about structures of buildings and constructions. Part 4, we have considered two main models, were connected with structural schemes of buildings and rehabilitation and difficult ground condition. So that's all for today.